Hi, everyone. We do have people joining us today from mostly from US. We also have some presence from Europe and India, and hence, good morning, good afternoon, and good evening to all the people who are joining us today. I would like to welcome all to this panel discussion on the software-defined vehicles. Here, we are trying to focus on the future of mobility and trying to address some of the challenges that are facing, adoptions, and how that are being addressed. Right, and I thank Kingsley for setting up the stage. So he very well captured three major items for me. Right, so one, the how the spend is increasing, which is driven by digital. Second, how the case which is coming into picture and how it is resilient even in the during the time of pandemic and even during now. And third, he pinpointed that going forward over next 7 to 10 years, the the revenue which is driven by software is going to triple. So it will be more than 20%. So all these three things set up really well. And during this panel, we do have, I'm privileged to have a very diverse panelists. We have from OEM, we have from tier ones, we have from semiconductor, which is enabling all this transformation. And we do have a person from technology providers. So it's a good combination. So it will be good to understand from all their perspectives. So as part of this panel, there are majorly three things which I'll try to capture. One is to understand the digitization. I say that it's the softwareization of the automotive industry. I'll try to capture or try to understand trends, technologies, the evolution within the automotive space. Second, the influence and also the impact of all this on the safe mobility and the security, which is the core for this automotive. Third, I'd like to understand in this adoption, what are the challenges are we normally facing and how they are being addressed. And all this, there'll be a lot more stories to be heard from the panelists, right? I hope now let's start with the session. So I'd like to start with a person who had the privilege to influence and shape the advancement of automotive world through both corporate as well as academia. So I'm talking about you, Tyler. So with a new venture you're into, which is mainly focused on the autonomous vehicle space, I'd like to understand from your perspective, what is the future of mobility? What is your vision for this future of mobility?
Well, a lot of people, when they try to predict the future, make the mistake of trying to predict the present. And we have to recognize that we're in the middle of a transportation revolution, which is driven by three things. The first is electrification, second is automation, and the third is concern about climate change. And we have a tendency in the United States, when we talk about mobility, to think about private cars, and mobility is much bigger than that. There are about 200 operational driverless light train systems running around the world. Mobility as a service is emerging, and it may mean that if the mobility as a service really takes off, it doesn't make much sense to own your own car, and that's all that's going to make a difference in how many cars are produced and how they are used. Several years ago, automotive companies were basically considering electrification as a sideshow, and they have now shifted their resources so that they are investing heavily in electrification and kind of deprecating the internal combustion. To a lot of the public, when they talk about automation, they think of Tesla. And in the industry, we know that Tesla offers level 2 automation, but so does just about everybody else. But level 4 is on the way. There are driverless taxis on the road in Arizona, San Francisco, and Beijing, which have gotten rid of the safety drivers so that they're really driverless. And I'd like to say that there is no reason to expect that the automobile as we know it will survive its encounter with becoming driverless any more than the carriage survived becoming horseless. So I think we really need to think outside the box and realize that, software is going to be producing a better vehicle, but there are opportunities to go far beyond that, and I think that we need to be aware of what the possibilities are. And I'll let you move on.
Thank you, Tyler. Thank you. I think that's a profound thought. So let me just go to Gary. Gary, we have seen you've been at the forefront of the technology over last 3 odd decades, and you have worked across some of the top players in the automotive space. So considering that, how do you see the evolution and adoption of software, or I would say the concept of digital within this automotive industry? When I say that, it's the connected, intelligent, the vehicles kind of.
Sure. First, I'm just going to say a bit about Marelli, since it's a relatively new company. And it was formed with a merger of Calsonic Kansai and Magneti Marelli. So it's a new company, but it's got its roots back in the tier 1 supplier business for a long, long time. So anyway, one of the things that I was going to mention is there have been a couple of things in the past. One, the emissions controls back in the mid-70s pushed the adoption of electronic controllers into the vehicles. And that was a major change to put something in the car that was electronically controlling the fuel flow and the throttle. So it was a very nervous start, because somebody said, how much are we going to be able to control them? Well, turns out that the electronics became much more reliable than the old mechanical systems. So that was a good thing. And the features in the vehicle, with even starting of the engine and steering and braking, the steer-by-wire, the brake-by-wire, and throttle-by-wire are the 3 kind of major things that push the controllers into the vehicles, providing a much safer, much more reliable experience for the user. So, I see coming into the future, this is going to just continue to grow. As you go to the electric vehicles, there's less of the need for some of the controllers for the engines and stuff, but certainly for the braking and the battery management and so on is all going to be part of the need for controllers in that area.
Perfect, Gary. I think talking about controllers, I think I would like to go next to Sudhir. Sudhir comes from the semiconductor segment, and Sudhir, we understand that the semiconductor, the industry, is enabling as well as it's accelerating the future of automotive technologies, right? So we can't deny it. And as the industry drives towards autonomous, connected, and electric vehicles, the semiconductor industry is enabling these players to accelerate both development as well as optimizing their performance, right? And we understand that you are very closely associated with the SoC design area for the automotive player from Samsung. So hence, want to understand your views on how your journey in this space has been, and also want to understand what are some of these chip makers, the leading chip makers are trying to solve in this next gen mobility space.
Thank you, Jay. So there are 2 parts to this question. The first one is the journey of a chip designer. The second one is what chip makers are trying to do in the next gen mobility. Let me try to answer the first one. So as far as the chip designer journey is concerned, if you look at the late 90s, early 2000s, when we're designing the chips that were non-automotive, right? We didn't have so many headaches, honestly, to deal with. But when it came to the automotive world, right, totally different kind of a flow, which is the EDA methodology, design, implementation, architecture, changes had to happen at all the levels. If I start at the EDA stage, what we call as a methodology for automotive, right? Now we need to take care of, right, in addition to the regular DFT logic that we have, we need to have logic BIS that is a must in automotive design. We need to make sure the DPPM requirements that are really stringent. And when we are trying to do the design verification and functional verification and performance verification, now for automotives, we have to do something like safety verification, fault injection based things. So all these things involve a change in the methodology, and a different type of flow specific to this automotive world was created in collaboration, chip designers worked with the EDA vendors, and they came up with this flow. Then came to the aspect of the intellectual, or the IPs that we use in these designs. They are not like regular IPs, that they need to meet more stringent conditions. They have certain specific ASILs levels, depending upon whether you are putting the chip in the ADAS or whether it's an infotainment. The PVT condition, the process voltage temperature conditions, they're all different for these. And depending on the grade level and ASIL levels, you have to make sure the IP is designed correctly, meeting those requirements. Otherwise, it's going to be a safety challenge later on. And all this falls under we have to adhere to the ISO 26262 safety regulation. And there's a FMEDA, FMEA, these kind of platforms which have been created to make sure that we meet these levels. This is just the silicon part of it. Now we have to make changes in the sense at the package level, make sure thermally and mechanically they are able to meet these requirements. Because if you look at a chip which is sitting next to the engine, which is really, really hot, right, has to be able to meet those thermal mechanical stress related requirements, right? And now as we move from this to the higher level, where we're coming up to something like an autonomous car, where we have created solutions, deep learning with the neural engine in the chip. You need to have 5G technology in place. It has to be all connected. And now we are going to the advanced node where we say it has to be a software-defined vehicle. No longer can you just rely on pure hardware, which is totally disconnected. You have maybe 100 plus ECUs in the car. You have 45 to almost 80 processors in the car, depending on which level, high-end, middle, and low-end car you're talking about. All these things, in order to move forward, make a progress, if when they are software defined, you need to have the capability over the ears to kind of download software, enable the piece of the functionality that you need. Similar to that, like in a mobile phone, right? You download an app and you use it. The car is coming to that level. That is the future of the car. And when we do these things at the semiconductor level, we have to make sure not only the SoC architecture, not only the system where we have to take care of the decaps, SI, power integrity. We have to make sure the entire vehicle, the OEMs, they are plugged in and they are in sync with somebody who's designing the chip. Their idea of the overall architecture matches and is very well aligned with somebody who's designed it, somebody who's designing the IP, somebody who's in the package. So this is where I would say where all of us work together and we make sure that we offer a solution which is totally software defined in the future.
Perfect. Thanks a lot. Thank you, Sudhir. And finally, Vivek, so I see that you have been associated both automotive as well as high-tech industry for over a couple of decades, right? And you have been working with large enterprises, and now you have your firm, and you have experience across the value chain and supporting them across various initiatives in R&D and services level. With that in picture, want to understand your thoughts around how have you seen in the approach of your customers or partners in the industry towards this vehicle digitization or a softwarization within the automotive industry?
Thank you, Vijay. It's an honor to be on this panel. So if you look at the automotive industry is going through a major disruption, we all know about this, right? And what has happened, at least in my experience, what happened in the mobile industry about 15 years ago, it's happening in the automotive industry. You're going from feature phones to smartphones, and automotive industry is moving to the software-defined vehicles. It's the fundamental approach is totally different when it comes to the automotive industry. I think one of my Sudhir and other colleagues talked about is that it's about layerization, to create the layers of different components as well as how the vehicle is constructed moving forward, and that disrupts the supply chain and dealerships and everybody else along the way. So if you look at so there are two major trends if you look at, right? Moving from ICE to the electric vehicles, because of the climate change. I think Tyler talked about it upfront. And what it does is that it also now starts bringing out the new electrical architectures inside the cars. Number of ECUs going substantially down, and then there is a segmentation aspects of it. We are seeing a lot of this disruption coming at the top tier of the segments of the vehicles. but from an end-to-end value chain perspective. So if you look at from a consumer, and consumers could be two type of consumers, basically. One is a B2B consumer, and other one is actually a regular consumer which buys the cars. And I would also like to suggest that it's not just disrupting in the passenger car industry, but also going to happen in the commercial vehicles as well as the two-wheelers and three-wheelers across the board. Now, having saying that, the number of silicon which is going to go and will increase substantially inside the cars is very much clear. So that's a one disruption that you see starting to see. The major players are coming into this in this foray, and there are three key areas where the disruption happening. One is on the cockpit, as you know, and the cockpit requires a lot of integration of technologies which are actually evolving from the mobile side, from the IPs from mobile side, because you need now looking at consumption of content. You're looking at how do you bring all the services. There are companies going into this foray like Amazon, Google, of course, Google Auto has been there in the past, and then we will start to see such more and more coming into the space. The second piece in this area is bringing the concept of edge or cloud edge inside the car, which is the hyperscaler integrations. Where the connectivity pieces are going to happen, and you start to see some form of disruption coming into the operator space as well from the connectivity pieces. We are talking about 5G today. It will start going. 5G is release 15, release 16 today. It's going to go to release 17, and maybe eventually release 6G. Now, having said that, car is not something like a mobile phone, which you just own it for 2 years or 3 years. Car is something people like to own it for 15, 20 years sometimes, right? And the software-defined vehicle aspect is the most important aspect of it, because people want to live through the experience and increase the experience as the issues come into new services started to get deployed, and which are not even imagined today. So you have to bring up the aspects of app stores. Now, today we are talking about walled garden app stores into this. So when we're staying in the high-tech industry, the key thing is that everybody in the ecosystem will start evolving into how to bring a best of the breed experience. Now, once you get into the autonomous side of the cars, now you're looking at how do you disrupt in terms of experience sitting inside the car, where you're facing forward, you're facing inward, So there are a lot of other aspects from a design perspective. So if you look at from an OEM perspective, if I would say the key considerations from the supply chain perspective would be supply chain and value chain perspective, how do I disrupt the consumer behavior? How would consumer have a better experience on something which they have never had before? And that's what some of the companies have been trying to do. But the other thing is that how do I increase the range anxiety? Reduce range anxiety and increase the range from the EV perspective. A lot of disruption happening in the battery technology, BMS software. The important part of it is the role of dealerships, for example. Will the role of dealership will diminish? Because people would not like to go. Today, you go to a dealer, for example, and it takes you some time to get everything serviced and all that. Now, with the OTA over-the-air updates, how will that reduce that time for you? So I think we'll see that a lot of major business models will start evolving in this whole space. There's a lot more to talk about in this area.
Perfect. Thanks a lot, Vivek. Thank you. I think you have set a good stage for my next question. So you spoke about the disruption. Right. And I leave this question to Gary. So Gary, we understand that the disruption or the way automotive industry is reforming with revolution across, majorly we would say that energy, ultimate energy or sustainability, then second is connectivity, and third being intelligence. And these are the new core driving forces within the automotive industry. And we understand that the software transformation seems to have disrupted the way Vivek just highlighted, the traditional way of thinking. It could be automotive architecture, the technology that are being used, the way you used to do the R&D, the research and development models, the manufacturing, and even the complete ecosystem, right? Gary, if you can share your views on the disruptions, how this transformation has disrupted the usual way of thinking.
Sure. The connectivity aspect of the to the vehicle is one area that opens up some very, very interesting applications within the vehicle. And we experimented with a system some years ago where we had a vehicle that was driven by several different people, and they rode through this specific pattern and or series of roads. And one of the things we did was we said, well, okay, with the connectivity and having the information on the roads, you could anticipate that there's maybe a stop sign ahead or something like that. And so you could control the vehicle a little bit to say, okay, I'm not going to let the vehicle accelerate to the stop sign and then make a hard brake. I'm going to make the vehicle just kind of slow down. And so the software in that system, when we did the evaluation with the software on and active, there was like about a 10% fuel economy improvement. And that's a significant thing, especially if you have a fleet or something like that. But the people hated it. So the people said it makes me feel like, and it's an appropriate comment, but that's okay. It makes me feel like I'm driving like an old lady. And so apologize for the comment, but there's also some data that we had on the trucking industry where they understood by tracking information about the trucks driving, the trucks using using cruise control had a noticeably improvement in fuel economy. So they put up a chart in the driver's room, and with a red, yellow, green, stop sign kind of information. And the drivers were looking and says, well, how am I yellow and not green? And I drive really good. And they said, yeah, but you're not using cruise control. So just something simple like that pushed all the drivers to move into a system where they were driving more economically. So those are things that you can do within the system, taking the data that's available from the information available on the vehicle and pushing it out beyond that in a ways that you can improve your business. So just some simple things there.
Got it. Vivek, coming back to you, just to complete the thought on the disruption. So can you just share some thoughts around, do you see any disruption in the architecture? Second is, wanted to understand, do you see the way we have seen across the software industry, the decoupling of software and the hardware, platformization, any cloud-led models? Do you see any disruption around that in the automotive as an industry?
So I think, first of all, there is a major disruption already happening. There's already thoughts about it. So I think if you look at originally, automotive industry was, when we get the vehicle out, everything has to be serviced by a dealership, or somebody has to walk into dealership to get everything updated. So we have now looking at the concept on OTA. So I think this is nothing novel now. Everybody wants to do it. The question is why, And from architectural perspective, from electronics and from the design perspective of the architectures, the important part is that you have two islands of it. So one is the mission critical applications, which are certified in a separate secure space inside the vehicle itself, so that they cannot be changed by any intruder or in any other ways. But then there's a non-mission critical applications, which people sometimes not even have thought of it, or the services people not even thought of it. So example would be cockpit, for example. In cockpit, there will be aspects of downloading a new app, which will communicate with the maps, for example, to provide a V2X or some form of new services which people have not even imagined on. So you will start to think about how do I bring in APIs or an SDK for developers to start building on it and test it part of it. The second approach, I think, which is very important when it comes from the software industry, is a spiral mode of development and testing in the areas where the things have not been tested fully, I would say 99.99 reliability testing in the non-mission critical applications. And you test it through the beta process, dog fooding process, and areas like that. And brings in how would you architect a software layers where certain things are exposed, certain things are not exposed. And that's where I think the OEMs are starting to feel a little bit of heat about it, in my opinion, because I think that's where the operating system control points have to be created, where they understand that what goes inside the vehicle in terms of when the vehicle rolls out and what we can go and update later on, and in a more safe and secure way. Now, having said that, this is where the important part of disruption also comes in the supply chain piece. At what point the fusion of sensors and how far you go in there, how many kind of sensors, how do you decouple those? I know there's a talk about, for example, LiDAR versus cameras and all sorts of stuff. Basically, we see that in one of the OEMs, they're using 8K cameras, for example. Now, instead of 8K cameras, and you're starting to see 16 of those cameras inside a car. Now, obviously, that will be high-end car. But can you use really all the benefit of 8K cameras today? But to use an 8K camera, you need to have a computing power of that kind of a computer inside the car as well. And that also brings in aspects of what kind of nanometer node and technology you need to bring from the power consumption perspective. So there's a lot to think from the architectural disruption perspective. Then comes to the cloud piece, what you talked about. And I think the cloud has at least I believe that the cloud will also go into a hybrid cloud situation where you have a cloud-based services where you also create a digital twin of the or which we call shadow mode of the car itself. So inside the cloud, so that there are certain aspects of things can be either predictably maintained inside the cloud, and they say, okay, this part may fail or some things are happening, so we should be able to disrupt that through over-the-air updates. So there's a lot of changes from an overall experience perspective will come down. And the last point I would like to make is that all this eventually will come down to a factor, I believe, and of course there's no quantization, a factor of 20-25% efficiency is minimum across the value chain in terms of bringing the things together.
Thank you, Sudhir. I think that sums up. And one last thing which I have is the growth of data. Data is something what we have seen during the pandemic across the industry segments, the consumer, the business. And we also understand that the data which is generated in the car would be humongous. And the demand for a computing and a communication ability in the vehicle is increasing because of that. So Sudhir, I'm coming to you, trying to understand what are the evolutions you're observing within semiconductor industry, or a SOC to be specific, to address this accelerating computing and communication demand within the automotive?
Yeah. So as you see, the number of ECUs increasing, a lot of audio, video data coming into the chip right now. Now the car has become something what we call data center on wheels, right? So as a result of this, you need a lot of compute. Now, you can always increase compute by increasing the number of processors. But when you look at the memory, right, the memory doesn't kind of give you the similar kind of advantage in terms of scaling, the way you can add a lot more processors. So there are ways of kind of addressing this. You can either do some kind of distributed computing. You will have compute and you will have SRAM next to it. So it has a cache next to it. You can do that kind of fetch. Otherwise, if it has to go outside the DRAM and get the data, then you're kind of limited in there. Now, in terms of that, the semiconductor industries, they have come up with this architecture where they can add a lot of compute and make the same sure the memory is not a bottleneck, and also the I/O is not a bottleneck. You will see the new generations of the PCIe and DDR. That's why they are coming up in order to make sure you have the right bandwidth, you have the right compute. And then when you add these inferencing, training, and all these neural engines into your chip, right, they have the other peripheral supporting IPs in terms of bandwidth, latency, and compute. And in general, right, if you see the communication now, and now with the advent of the 5G and all that, right, we are able to get that 1 millisecond latency, and in terms of the vehicle to infrastructure or vehicle to vehicle or things like that, right? This is the thing where it can really result in that kind of autonomy, where a car can take a split-second decision once your camera captures a pedestrian or things like that, and you're able to make sure you are able to drive safely, right? So I think with these two things, we are we're on our way right now. We are say level 3, level 4, and moving forward. It's quite some time till we reach level 5, but at some point of time we'll be there. Yes.
Perfect. Thank you, Sudhir. So we covered the evolution, the way the adoption of some of the use cases, the technology advancement which is happening. Considering it, I would like to go to Tyler to understand as an automotive industry, it always ensured and upheld two major factors. One is safety and other one is security of the passengers, of the people inside the car and outside. And with this, all this advancement which is happening, the vehicle itself is continuously evolving to be a hardware and a software platform now. That's what we heard, right? And I want to understand from you, Tyler, how do you see the influence or impact both ways on the safety of the mobility and the security of it from this all advancement, what we're seeing in the world?
So Vivek has talked quite a bit about over-the-air updates and consumer demands for new applications, and that scares me because the consumer software model is you ship buggy software and then you update it every few days or so to fix it, and that's a model that's simply not going to work in the automotive industry. You have to look at security from the very start. And Vivek made the distinction that there's between the safety critical aspects and then there's the infotainment systems. But as we saw in the Jeep Cherokee hack, that you can go from the infotainment system and get into the critical parts. So you need to be able to compartmentalize the different parts of your system to make sure that you can't get from one place to the other. And I kind of like the old-fashioned idea that you need to take the vehicle into the dealer to get a software update for the safety critical parts of the system. Now, you might have all these apps that you want to download to do things that are not safety critical. And one of the questions we had was on what's the importance of V2V and V2X. And one of the things you have to bear in mind is that V2X can be useful, but it can also be spoofed pretty easily. So you have to be careful that the information that you're going between vehicle and vehicle, V2X, is useful, but you can't put too much credence in it because you don't know how reliable it's going to be. So there's, yeah. A whole lot of things to consider. That's a start, some of my ideas.
Got that, Tyler. I think, I think, yes, with the advancement, yes, there are challenges, what would come. And I would like to ask each one of you different aspects that you see, I would say, the roadblocks or hindrances or the challenges, what you're seeing. So let me just start with Gary. So Gary, considering this digitization or softwareization, the advancement, what we're seeing in the automotive industry, what are typical technology or R&D led challenges, what you're seeing in the industry, in the adoption or the implementation of it?
Okay, first of all, I'm going to make a comment about V2V, V2X, okay, because I've worked on that a lot in the past, and there certainly are some concerns about security. At the same time, that's one of the systems that, if it's implemented, could significantly reduce the number of fatal accidents on our highways. So you have to weigh, the risk of having something, taken over versus the overall safety. And some of the government statistics are, if the C-V2X or V2V were implemented, it would maybe reduce accidents by maybe 70–80%. So anyway, so something to think about there. But then as far as trying to understand how to make sure the stuff is going to be reliable, it's just a matter of testing. And that gets into a whole, area where we have whole type, validation teams that go in and try to understand where all the weaknesses are in the code and how to be able to analyze those and understand and try to fix them before they get on the field. So I'm going to just mention one other interesting topic. And that is, there's an article out there about a quadriplegic that's controlling a race car from his bed just with mind waves. So here's another technology maybe coming along to say, maybe if I'm in the car, maybe I can just think about what I want to listen to or think about where I want to go, and the car could do something. Now, that's probably a long ways away, but just interesting to think about.
Got that.
I have to disagree with Gary that testing is the answer to everything. When you get into embedded systems, there are so many systems where you've got an interrupt can happen at exactly the wrong time and can screw up things, and you cannot test around that. You have to design in from the start that things are going to be reliable.
I'm not going to disagree with that. You have to go back to the basic design, but eventually you've got to put stuff on the road and find out.
Right.
Got that. And third major aspect, what would like to, I'll go to Vivek for this. Considering we spoke about the technology, we spoke about various structures, the R&D. I would like to check with Vivek. We have seen the struggles what OEMs are going through with respect to how to adopt the fast-paced change and the talents. So Vivek, I want to understand from your side challenges with respect to organizational, the structural, and the talent, the availability of talent per se. Do you see any challenges in this advancement journey within automotive?
Yeah, so I think what we have observed, I'm talking on behalf of Wipro as well, that first of all, if you see, Wipro provides end-to-end in terms of from a semiconductor all the way up to the cloud and even the applications and areas like that. And what we have seen in the OEMs and other parts of the value chain, that there have been several silos inside the organizations which have been working a traditional value chain of delivering vehicles, which has been there for the last 30 years or even more, I would say, 100 years. So I think those silos have to be broken down. That's on one side, because everything has to work in tandem, and you have to work in the areas that life of the vehicle is no longer, as I mentioned earlier, it's about that I sell the vehicle and some little bit updates every 2 years or 3 years recalls have to be done. Now you're talking about continuous advancement of providing the services and software updates and areas like that. So that means that all the departments inside the organizations have to work very within the OEMs much more closely together and work as a single project of bringing the things together even after the vehicles are sold and over the lifetime of the vehicles. That's one. On the second question of the talent itself, now the type of talent needed is the demand is humongous. And the type of talent needed is no longer, where has been traditionally there. So now you're straddling between the different industries to bring the things together. And some of those industries may not have had, for example, cloud, for example. Now the cloud guys in the past may not have had as much as work going on with the embedded integrations with inside the vehicles, for example. And one of the colleagues on the panel talked about the kind of silicon and kind of SoCs which will be provided in there. So now they need to work on from the baseline of the silicon vendors itself to integrate the things. So there are aspects of these things which are creating a lot of talent shortage in the industry. Which can straddle between the automotive and the traditional industries as well, because things are coming now together across the board. The other aspect, which is very interesting, which at least I started to see, is that when you bring in such kind of talent, the cost of the talent is also increasing quite a bit. That will also decrease some form of margins, operating margins for the certain companies as well. So the companies need to start thinking about, how do I monetize my investments in a certain area? And that's why we are starting to see, how the control points of different operating systems have to be put together by different companies, and then they will monetize that over the next 15, 20, 30 years, for example. So there is a lot of happening in the talent shortage. The cost, as I mentioned earlier, is important. The talent itself, the kind of talent you need, and how the talent will be managed as well is another important part of it. Because now you're looking at creating the teams which can work together much more in an agile way. So the kind of process which needs to be implemented, which has not traditionally been part of the automotive industry.
Got your point. Got your point. So let me go to, I think, another important challenge which automotive as an industry is facing is on the semiconductor. The two aspects of it, one is supply chain and the shortage of semiconductor chips. And we have seen across the globe, the delivery of the vehicles being stopped, or sometimes it is delayed due to this. So I will go to Sudhir, trying to understand how this panning out and what is the near and far, what is there for us to, with respect to semiconductor shortage, how should we tackle it, and what kind of challenges we should expect?
So all this kind of, I would say the major contribution to this shortage that happened was primarily due to pandemic. And then on top of that, we had Russia attacking Ukraine and natural disasters and things like that. It made kind of situation really worse, right? Now, in order for OEMs to plan things correctly, right? Previously, they used to order a certain number of parts and their inventory levels would be at a certain level. But now with the change in the landscape, they have to kind of proactively procure more just to make sure, especially when we are trying to do the software-defined vehicle, right? You can have a piece of functionality which you are like an independent ECU or which you can test by itself. But when you are going to this concept of SDV, where you want to have, okay, I want everything to be connected, and then I want a download to happen, and I want to test it, right? If you don't have a chip because of the shortage, if you don't have a piece of the hardware, then it's not going to fully be totally realized. You may be able to do it in parts, but that's not serving the purpose. It will kind of slow down this this progress that we are making on this front. So as a chip designer, as an OEM, or we have to make sure when we design these days, right, we are in sync with the foundry. Foundry is going to tell us, right, at what point of time the tape out is going to happen. You as a design have a planning at what point of time the tape out is going to happen, and whether that agrees with the foundry, because they have a certain capacity limitation, right? So gone are those days when you would just get a PDK, DK, and then kind of start designing and then, okay, throw the GDS, okay, this is, please go ahead and fabricate. No, those days are gone. Once we go back to the normal way of operation, probably it might be something similar. But the way the things, the number of volume production that has to happen, all these things have to be planned well in advance. Now, in order to mitigate it, if you see the US government also realized the need, and they came out with the CHIPS Act, which they're saying that, okay, we want to bring the fabrication back to the United States. And not only US foundries, even foundries from other countries, they are also setting up fabrication plants in Europe, just to mitigate the supply chain problem, right? So everybody has taken a step in this direction, but this is not a small time investment. It takes a lot of money, and it needs a lot of skill, and it needs a lot of planning. So I'm happy to say that all the different ecosystem partners, foundries, and even the government is supporting this effort. It's just the need of the hour is that everybody has to align and kind of plan properly in order to make this happen.
Got that. Thank you, Sudhir. And one, I think the last lever in this aspect is the ecosystem, challenges on the ecosystem, any changes in the value chain. And the most important is the impact on the business models, the traditional business models. So I'll go back to Tyler to understand his thoughts around these three aspects.
Well, to me, I think that we have to understand that transportation is about a lot more than just the vehicles. That building your ultimate dream car doesn't do you much good if it's stuck in traffic. And there's a whole lot of software issues involved in automating the individual vehicles. But looking into the future, I think that the really exciting part is looking at the traffic control system. I can foresee a day when we have all these vehicles that are automated and connected, and it's not up to the individual driver to drive them. The control of the vehicle is likely going to be external, and we would basically model that off the air traffic control system, where you've got a sector that is computer controlled and is responsible for the safe operations of all vehicles in that sector. And then when a vehicle leaves that sector, it basically hands off to another sector so that you keep the system scalable. And I think the control of the basically overall vehicle operating system, the traffic control system, is really the huge opportunity in the business. Microsoft controlled the operating system for personal computers and wound up being a $1.9 trillion company. And I think there's a similar opportunity down the road once we have a large number of vehicles that are automated for somebody to jump into this. So that's a really futuristic prediction.
Got that. Got that. So I would like to maybe take one or two questions from the audience. Let me just, I think this question, let me just start with maybe Gary. So Gary, one question what we received is the point which Sudhir highlighted is regarding the importance of the close development, the R&D which a company need to do on the chipset side of it. In addition to that, we are also observing how OEMs or the automotive players are investing in chips design. So the reason why they're trying to do is to control over the design so that they can work very closely with the IDMs like Samsung or Intel or Qualcomm's of the world, so that they can improve the time to market, the customization, the factor of differentiation, right? And want to understand from your side, Gary, how do you see this panning out, that chipset design being within done from the OEM's point of view?
It's true that the OEMs would like to be in that area and be involved in that, and where it makes sense, that's probably a good thing to do. But their expertise is designing and building cars, and when they have moved away from that and tried to get more into their software, writing their own software, designing their own electronics, they typically, at least from my experience anyway, they typically aren't as nimble enough as smaller companies to be able to move quickly and make decisions and move fast. So I suspect, I mean, there's a lot of changes going on, and it's not the first time that OEMs has said, okay, we're going to take on and do all our own software. And in the end, they wound up, maybe that will work. It's not saying you shouldn't try something like that every now and again, but there's a reason why the tier 1s and tier 2s and 3s are still pretty healthy. And OEMs design and build cars, and there's a lot of new stuff coming with that. So they need to focus on that.
Got that, Gary. Sudhir, do you want to add anything on this perspective?
So what I would like to say is that we have to be open to the fact that when OEMs at the end are responsible, right? They have to kind of make sure that the car is out ready for the consumer, right? With all its safety, functionality, what they had promised, right? Mm-hmm. Now, they cannot do it independently. They have to work in an ecosystem, right? That means some part of the initial work that they were doing, yes, it's right that they are actually good at building cars, right? But if you look, say, for example, Tesla, right? They built a car, but they built a smart car, right? So the only way they could have done it is that when they had the hardware, software teams in-house, right? So similar to that, right? If all the other OEMs are trying to compete with Tesla, they're trying to follow the model, they have to change. It's necessary, but they cannot design the chips all by themselves. It's true. It's a lot of work. It doesn't actually make sense also. They have to work with the IP providers. They have to work with the ASIC houses. They have to work with people who know the SoC architecture, system architecture, and that piece has to be integrated within their own individual vehicle architecture. So I would say there's a need for change, but yes, they cannot do what actually an independent chip designer or an actual company which is doing all these things for so many years. It's not so easy, especially at advanced nodes. It's very difficult.
Okay, got your point. So I think what I understand from Gary and you is it's an ecosystem play, and players should start working together, and that's how the success is. And I'll take maybe one more question from the audience, and I'll take to Tyler. So the question is, there's a lot of hype around the V2V and the V2X communication and the possibility of that across the safer roadways, the more efficient travel and others. So the person want to understand is it realistic in the short term? What are the realistic possibilities around it?
Well, for the short term, you need to have the connection, and I think that's going to be a longer term development to get to where we actually have the connection. We need to have some government mandates to get the systems in there, and until we have a large scale deployment, I don't think that's going to make a whole lot of sense. As was pointed out, the V2X does have tremendous safety implications, as has been shown by a bunch of data. And yes, I think it's something that will happen. And there are security concerns as well, but I think one of the things you have to realize is that if you're doing a Wi-Fi connection, you have a lot of time to authenticate between two systems, and you can have a lot of stuff going back and forth. If you got V2V, you can have just a fraction of a second at which you're in touch with another vehicle that's giving you some information about what's up ahead. And it's a lot harder to authenticate that that's true information. So you have to kind of take it with a grain of salt. So that's maybe a roundabout answer, but in general, yes.
Okay.
But if everything else, there's difficulties, there's details.
Got that, Tyler. So let me just go back to the flow, and I'll go to Vivek. Vivek, we heard about various challenges across technology, R&D, the talent, the supply chain, the semiconductor. We also spoke about some of the business models. So want to understand, so one thing we understood is the ecosystem is very important and the leveraging that is very important. And I want to understand, so we spoke about the OEMs, tier ones, we spoke about the semiconductor, all the enablers, what we have. The one more enabler here is the technology service providers, right, who support across this value chain. So want to understand from your side how a technology service provider like Wipro, for example, is enabling this change and addressing some of this the challenges what we just discussed.
Yeah, so I think a very good point. As you see that this whole value chain and the desire to have better services and across the board is actually bringing the need of much more integrations on the fly, as well as integrations and testing and all across the IPs, which has to be integrated across the different parts of the value chain. And starting from the embedded itself, I can tell you that, for example, Wipro has been building this cloud car initiative, in which bringing the ecosystem is a very important part of it, to build in the silicon providers in there, bringing also the aspects of mission critical software IPs, the middleware, the application IPs for app stores and areas like that. So this is an important part of the equation, because this is what has not been traditionally inside the OEM industry. So what the system integrations aspects bring in. To the point of Sudhir also brought about building the silicon, I think eventually to create a better differentiation, which is not between the OEMs. I think at one point, either through a custom silicon aspects, the OEMs would like to build their own silicon. Maybe they don't do it themselves, but they will work with in partnership with the silicon. That's part of another ecosystem aspects which coming together, which was not traditionally there. Then you look at if you peel out the layers of the ecosystem, then you look at the cloud providers. So as you can see, there are different cloud providers. They are very much have been working in the areas of ingress of large amounts of data, which we're discussing about, and large amounts of data. And also, where do you go and process that data? I mean, sometimes the car is not always connected, as much as we want it to be always connected, but may not be always connected. So now looking at the ecosystem players who will be companies, those who are bringing the hypervisors, those who are bringing, for example, the areas of Kubernetes or containers and like a VMwares of the world and so on and so forth. So I think the companies like, for example, Wipro is very much well poised, who has worked in the end-to-end value chain in this area. When it comes down to the dealerships and other parts of the supply chain and manufacturing itself, right? So that's also getting disrupted. So for example, the traditional tools which were used for the designing the vehicle part itself is the mechanics and all those things are still the same. But when you look at the electrification aspects of it, now you're looking at the ecosystem of bringing the different kind of battery companies. You're looking at the BMS, you look at the power management aspects in there. So, and these technologies will keep on evolving. One thing I do want to say is that as much as we thought that the cars will be there, the same architectures will be there for next 20 years. But when you go into the compute intensive car architectures, for example, moving forward, I think there will be a point where the compute platforms of the car may need to get replaced during the lifetime of the car to keep it evolving and keep it refreshed. And given that, for example, today what the computer which you get or compute platform which you get for X amount of price, you will probably get 10x of the same performance for the same price in 10 years from now, right? So maybe even more. So now, and then you will have more sets of services and applications. Tyler talked about V2X. V2X is a concept, today, and protocols are there, things are there. But how do you exchange the data, and that how do your new business model will emerge? That may even drive new computing requirements, for example. So you'll start seeing that at some point the blades of the inside the car or vehicles will need to be changed. And specifically, people would not like to buy a car and say, okay, it becomes obsolete in 80 years, for example. It's a lot of money to be put in there. And I also see that there's a lot of advancement in the batteries systems that are coming together right now. There's a lot of innovation happening in the batteries. So given all these aspects of the ecosystem becomes a very, very important aspects of it. And it's not only just the ecosystem from one-to-one relationships, but also multi-party relationships between themselves to create a much more effective and roadmaps, which allows them to bring the innovation inside as the vehicles move forward. Right now, most of the innovation is, I would say, happening at the top tier of the value chain. So because they want to bring $100,000 cars or $90,000 cars or $50,000 cars, for example. But eventually the consumers will want to see this whole thing coming down to $15,000, $10,000, $8,000 vehicles as well. And we have not talked too much about the passenger vehicles itself. I mean, mostly talk about passenger vehicle cars today, but the commercial trucking industry, two-wheelers and three-wheelers, this is where the disruption is also needed. And that's where the ecosystem approach is very much critical.
Great. Thank you, Vivek. So I'll go to the
yeah. Can I make a comment on that? Vivek was mentioning the need to have something that lasts more than a few years and upgrade software platforms. And if you look at the military and aerospace, that's been their experience with safety critical systems. On the space shuttle, when one of the astronauts took up a laptop computer with them, he had more computational power than there was on board the spacecraft. And once you qualify something to meet mil specs, then it's obsolete by the time it's deployed. You have something like the B-52, which has been in service for 50 years or so, and they need to spend major money upgrading the avionics on that. So yes, there's a need to redo the compute platforms, and it can get quite expensive.
Got it.
Thank you, Tyler.
Got it. So I think I'm actually, I have a couple of more questions, but maybe I'll share with all the panelists at the end of the session for them to comment on. Then actually I'll pass it on to the audience. But I have last one question where I would like to get all views from all the panelists is, we spoke about the softwareization or digitization. We spoke about the case segment. I want to understand, if I look maybe 10 years fast forward, what lies behind this digitization or a software-defined vehicle? So what is after this? So what is next in the automotive revolution? So I want to understand from your perspective. Maybe I'll start with Gary.
I think as you look down the road and we see more and more autonomous vehicles we've already seen this with Too Simple taking their drivers out and running vehicles, on specific routes and stuff. But one of the things I like to think about is what's the interface going to be in an autonomous vehicle when you get in, so that you can tell it where you want to go and what you want to do. And so there's two aspects of voice recognition that you need to think about. One is just the voice recognition itself across the spectrum of accents and everything else to be able to communicate. And then the other thing is the security side. And there's work being done now about not just voice recognition, but voice authentication, so that if you can register ahead of time so that your voice is kind of the key to allow you to access the vehicle and tell it where you want to go. So I think voice authentication is one technology that's coming along. It's got quite a ways to go yet, but it's certainly one of the new things out there.
So, Gary, what happens when you have a cold and your voice changes?
You have to consider all those kind of things in the software. Okay, can you distinguish enough of the details of the voice during a cold versus not a cold? Those are things that you gotta think about. Yes.
Perfect. Taylor, from your view, what do you feel?
So my view is that in the next 10 years, the next transportation revolution is going to be post-automotive. And we want to think outside the box. Once we have connected automated vehicles out there that work reliably, the costs are going to come down, the accident rates are going to come down, which means that motorcycles are going to become almost as safe as an SUV, and they can become the driverless taxis of the future. Americans are driving about 2 trillion vehicle miles every year, but 2/3 of those are urban, and the urban trip is only 12 miles. And as personal car ownership decreases, people are more likely to take a vehicle that matches the particular trip that they're on. And that vehicle might be something like look more like an overgrown bicycle. So the distinction between a single occupancy vehicle car and a bicycle may start to blur just as the public-private thing starts to blur. So I think we really need to start thinking outside of silos, and particularly once you go to light vehicles, you get to the point that you can recharge them by swapping batteries, because you have a light battery on it, which means that you no longer have range anxiety. You can just pull into a gas station, swap out batteries, you're on your way in less time than it takes to fill a gas tank. So there's a lot of innovation that we need to give thought to.
Interesting. Yeah, Taylor, I'll go to Sudhir to get his views on what can we see in 2030.
Well, definitely we are going to try to make it more autonomous and all that. But I remember I once came across, I think Elon Musk was saying that now that your car, right, it's going to earn money for you. When it comes to the autonomous, right, you don't need to park it, right? You can just rent it and then it'll earn money for you. So anyway, so coming to this is just regarding the commercial vehicles. What I feel is that there is one more aspect to it. If you look at defense forces, the way the terrain in which they work, right, it's not like smooth the way we have. Even if you put, as of today, all the autonomy in place, the road still needs to be straight, right? This kind of architecture or this kind of capability cannot work in a rough terrain, right? So in order to solve this problem, right, DARPA came up with the concept of saying it's a robotic car which is autonomous, but it's resilient as well. What it'll do is that it'll be able to navigate and drive on its own, like across a mountain. And if you and this has already been actually, NASA has collaborated with a couple of universities, and they are working on this concept as of now. And it's going to happen because this is the way where this kind of technology can be put to use, where nothing exists as of today, right? And if you take it one step forward, tomorrow people really start to live on other planets, right? And there are no roads there. You need something like this, where you first start off and then build the roads. Right? It's too far out, but it's going to happen someday. That's what I believe.
Good. Thank you, Sudhir. So last, Vivek, your thoughts. How do you see this is panning out?
Well, we have some. Sudhir has brought up some wild ideas, basically, which I think. I mean, we can always go all the way to Star Trek kind of things. You know what's going to happen, but I think 10 years is not too far. Actually, if you look at it, I believe that we are already looking at the SOPs of 2026, 2027 in the cars, for example, right now. But I think the main thing, what I believe Tyler also brought up, is that when the network effect of connecting the cars or the vehicles and bringing the multimodal transportation aspects and reducing the cost of ownership of the car. I mean, not even ownership of the car itself or the vehicle itself, but also ownership of the drive. How would you do? And today, for example, if you look at in logistics or even in the Uber, for example, I mean, there's a lot of cost of a driver inside. People are making money, and the issue what we need to look at is that once the car becomes autonomous, and now we are talking about certain part of the hemisphere of Earth. Other part of the hemisphere will take a little bit longer than 10 years, I would say, because roads are not that great over there in some areas. So once you have an autonomous cars, it can do self-parking. It can do a lot of things for you. Maybe at some point will probably bring the groceries for you as well, because you can and you probably don't need that. You probably get it from some of the third-party providers right now. But the main thing is that if a cost per mile today costs $2, for example, right, and it becomes an autonomous car and it has batteries and solars connected along with it, I would say that the cost will come down to 30, 40 cents per mile, for example, right? For at that point. I mean, of course, without inflationary aspects, we are getting in there. Now, if you do that, so if you do the math, then it does not make sense for people to own a car as long as you have a SLA between the companies and consumer that, you know what, anytime I want a car somewhere, it's already available within 2 minutes or 5 minutes or whatever it is, right? So that's one part of it. The second, I think, the safety part of two-wheeler vehicles, for example, I mean, we already seen, I think it was BMW at one point showed that the vehicle, the motorcycle can drive by itself, for example, scooters can drive by itself, for example, right? And I think if those kind of things will come together, so in the roads in Europe or China, India, and other places where not all the cars can be there all the time. So you probably will start seeing different parts of vehicles, for example, or different types of vehicles, two-wheelers and safe two-wheelers coming in for transportation purposes. The third aspect, I believe, is again going back to the services and new business models. I think we have not yet seen what kind of new business models can emerge, right, in this whole area. I mean, I can even say that, I mean, just a provoking thought, I think somebody showed that on a Tesla computer, they did a Bitcoin mining, for example. It was like 6 months ago or something. I saw something about that. So can you do the Bitcoin mining? Your car is sitting inside your garage and not doing anything, and you can just do Bitcoin mining or some kind of cryptocurrency mining. So there are a lot of other aspects which will come together. Now you have a computing resource sitting in which could be used for several other areas, which has not been the case in the past. So now we have a computer on the network. Now, the last piece is the connectivity piece. I think I did allude about that. I think in 10 years from now, I can almost say that 6G will be here, at least they'll be pushed through economic models and other areas. The 6G will be coming. Now it's not ratified yet, but it's going to come. So that will bring new sets of services, which will be included as a part of the cars and the vehicles and how people will live and how to communicate and so on and so forth. You should be able to go and communicate from a car and should be able to go and see a car or vehicle or whatever to inside your safety integrations inside your home as well. We're already starting to see those kind of services coming together. So I think 10 years from now, our life should be in one way much more interesting and simplified, but at the same time, I would say it will be much more on the network. People will know where you're going all the time.
Thank you, Vivek. I think that was a good set of use cases across from Gary, Tyler, Sudhir, and you. So thanks a lot for your time and taking time on this Friday morning to share your thoughts, your experiences, and a lot of stories. I think this will surely help our audience And I'm good to see that the audience are still sticking together, listening to it. So I'm still have 2 more questions, but I'm running out of the time. So I'll leave it up to Natalia to invite Vivek for the final thoughts.
Sure, I can just share a few more points. First of all, I want to thank on behalf of Wipro to everybody on the panel and as you know. But the important part I would like to say that the industry has to work together across the board. And from a system integration purposes, bringing the different parts of the value chain coming together, Wipro has a very good end-to-end capability to be able to pull the things in terms of from the cloud all the way to the silicon and work with the OEMs and other tier 1s and tier 2s and software vendors across the board. But the important thing I would like to say is that the ecosystem is an important aspect of this. I don't think so that this can be done an evolution without an ecosystem development across the board. The second piece I would like to say is that the talent is an important aspect of it. I think it's going to be more and more difficult to keep and retain the talent and also make the talent work much more efficiently. That means a lot more product management, project management, program management aspects has to be embedded as part of the integrations, which we see through. The third piece is I believe to also bring this work, which has to also extend not beyond just on the passenger cars, but also the other aspects of mode of transportation for logistics and supply chain areas like that. And the last piece is that I think that we'll start to see a much more disruption coming because of the market forces as the things are happening. You know, car makers have been very good in designing the car. I think people consume cars not just because it's the best software on it. I think the people will consume car because it's a good design coming through it, and they like it and they like the thrill of riding a vehicle and having the best services. And with that, thank you very much.